The main objective of our lab is to develop physical understandings that in time will help the engineer to design and develop protective means for infrastructure, houses and vehicles. We can conduct explosion-like experiment under controlled environment with no damage, no harm to the systems, no harm to the people who operate the systems. We take advantage of the advanced diagnostics that we have in the lab that is almost impossible to use in the field test. One big step forward that we did in this lab is developing the blast simulator, which can give us the ability to conduct a real blast explosion in a small scale size. With this knowledge, we can design, we can give tools, we can help to construct better protective building against threats. One of the test cases that we checked in our new system is simulate blast that initiate under a bus. By using high-speed photography, we monitored the blast propagation, and from that we can reinforce the bus in specific position. We can predict where the survival will be. This will help us to better protect the people in the bus.
Let's assume there is a bomb in the street, and we need to know how far to push people back so they won't get hurt. My research will help to determine this distance. When shock propagates in urban scenario, it actually creates a complex flow field, which affects the load on structures and human nearby. I'm using numerical tools to investigate this kind of behavior.
The research we're doing here starts from the basic physics, and we are trying to move up to the applied field to find a way that we can implement our results in the field. Our end goal is to develop the protective means and to better help to protect people and the building and help them stay alive.
We are the only universities that have such a lab. We are doing research for some private companies who are developing and building shelters, are using our laboratory for testing their equipment and their products.
Our group works on the fabrication and testing of light armored ceramics with low density and very high hardness. These ceramics may be used for personal armor, for helicopters and the system where the weight is the very important issue. And the fabrication so-called polycrystalline transparent ceramics, the efficiency of transparent ceramic is sufficient to stop bullets and PA penetration. The transparent ceramic may be used for windows of armored vehicles and for the mask of the soldiers and other armor application, and also for the civilian application, for example, medicine.
My research focuses in protective means for structures and infrastructures. The protection is both against war and terror activities, against explosives, accidents, and we are also dealing with upgrading structures, protection against earthquakes. Our duty is to give advanced protective means, mitigate with blast and with fragments. The structural engineering department is unique in the combined efforts it is giving in the protective technologies discipline and the seismic engineering discipline, and with this synergy we are improving the scientific and the engineering ways to deal with these hazards.